So section 4.1 is talking about factoring expressions with fractional or negative exponents. So before we jump right into that, I want to come over here and talk a little bit about factoring in general. So let's just go backwards in time to some algebra factoring that you learned a long time ago, that if you have something like x to the fifth plus x cubed, and you were asked to factor out the greatest common factor, recall that what you actually factored out was the smallest exponent you saw. So you factored out x cubed, and then you went through some kind of mental process to figure out that x squared was what you needed in the first position inside the parentheses. So I don't know if you did 5 minus 3, or I ask myself, what do I need to add to the 3 to get back up to 5? Either way, you get x cubed, the greatest common factor, which is the smallest exponent you see, and then you say what's left to go inside the parentheses once I have factored out the x cubed. So let's do another little example. If I get x to the seventh minus x to the fourth, and I'm asked to factor out the greatest common factor, you would go for the smallest exponent, the x to the fourth, and then you'd either say 7 minus 4, if that's how you think of it. Some people do x to the seventh over x to the fourth. Whatever way you think about it, you would get x cubed minus 1, and then you would need to factor that more because that's a difference of cubes, which we'll talk about more when we do a factoring review later. So now that we've reviewed kind of simpler factoring, let's look at one that's a little bit more complicated, but see if we can bring the same thought process with us. So if I have x to the 3 halves plus x to the 1 half, the idea is that you still factor out the x with the smallest exponent. Well, that's going to be x to the 1 half. That's the smallest exponent I see. Then I'm going to open a parenthesis and say, same process, what's 3 halves minus 1 half? Well, that's 1. So x to the 1, but we don't usually write the 1, right, when it's a power of 1, plus, and if I factored out the whole term, I need a 1 for a placeholder so that when I distribute, so always check factoring by distributing, and remember that if you're multiplying x to the 1 half times x, you add the exponents. Okay, so let's take it one step more complex, where we have x to the 1 half plus x to the negative 1 half. Same procedure, we factor out the x with the smallest exponent. So negative 1 half is smaller than 1 half. Then I'll have x to the power of 1 half minus negative 1 half. So that's the power of 1, which we don't write, plus 1. And then again, distribute and make sure that your factoring works. Okay, so that's factoring. This is factoring out a fraction exponent. This is factoring out a negative fraction exponent. So let me show you another way to do this last one that some students prefer. So I can rewrite x to the 1 half plus x to the negative 1 half as the square root of x plus 1 over the square root of x. And some students just prefer working with the square root. So I need a common denominator to be able to add fractions, so I would multiply the first term by square root of x over square root of x, and then the square root of x times the square root of x is x. Then I would combine the numerators and don't change the denominator. Well, this is the same thing that we got, x to the negative 1 half times x plus 1. But my instructions are always going to say, write your answer with positive exponents only. So you'll need to write it as x plus 1 over x to the 1/2, or you can write x to the 1/2 as square root of x. Either of those is fine. Okay, so now we've done a little refresh on factoring generally. So let's look at these examples. And the first one, you need to notice that there's a plus in the middle. So there are two terms. They're really big terms, but there are only two terms. So we want to find the common factor. So I see a factor of a 3x minus 1. And then I'm going to look for the smallest exponent. So I see an exponent of negative 1/4. Then I open a parenthesis, and I see that I have a 2. And then I'm going to have a 3x minus 1, and it's going to be to the power of 1, because 3/4 minus negative 1/4 is 1. Plus, then I factored out this entire guy, so a 5x is left. And then you need to simplify what's inside the parentheses. So you're going to get 3x minus 1 to the negative 1/4 times 6x minus 2 plus 5x. And then you need to write your answer with no negative exponents. So you're going to have 11x minus 2 over 3x minus 1 to the 1/4 power. And if you like it better, you can write it in the form of a 1/4 root. So remember that to the 1/4 power is the same thing as the 4th root of. Okay, so let's look at another example. In this example, we're looking for the smallest exponent. So that's going to be x to the negative 5. So that leaves a 4 from the first term, then minus a 7, then negative 2 minus negative 5 gives me a power of 3 that I need to have on the x, so that when I distribute and add the exponents, I get back what I started with. And then we're going to write our answer with positive exponents only, so 4 minus 7x cubed over x to the 5th. Okay, then we also are going to need to remember all the other factoring strategies that we know. Knewton will take you through a review of that as needed. In this example, we have a greatest common factor of an x. Every term has an x. And the leading coefficient is a negative 5, and negative 5 divides evenly into all of the other coefficients. So I'm going to factor out a negative 5x, which will leave me with an x squared in the first term, minus 10x, so that when I distribute, I get back what I started with, plus 2. And then that trinomial can be factored more. So that's a trinomial with a leading coefficient of 1, has 3 terms. So we're going to factor it, whatever factoring strategy you have. It's going to be in 2 binomials when we're done. So we're turning a sum of 3 terms into a product of 2 binomials. Well, the only numbers you get are a 2 and a 1 for the lasts. So I'm not seeing that you can do any factoring that works, because there isn't a pair of factors of 2 that add up to negative 10. So we're done once we've factored out the GCF. Okay, then let's look at B. I'm going to write it larger so I can see it better. And we look at all the terms and say they each have an x. And then 2 divides evenly into each of those coefficients. So 2x is my greatest common factor. Then I'll have 7y minus 5z plus 4w. So there's my answer. Okay, and then these are worksheets again. So remember that you can find the answers. The worksheets are in in Canvas. And let's do this one more example here. Here I have a 5 as a common factor of both coefficients. The smallest exponent I see on the x is x squared, which is going to leave me with an x squared minus 4. But that's a difference of squares, so I need to factor more, because you need to factor completely, as much as you can. So you would factor that difference of squares, and there's your final answer.